Morning, my name is Major Jason Casper-Grenier. I'm here with VMA 231 and we're going to go over the AV-8B Harrier. As you can see, this is going to be a single seat cockpit high wing. And this is primarily going to be a air-to-surface type attack platform that's currently used by the United States Marine Corps. We only have 2 squadrons left. It's slowly sundowning. We only got about 2 more years, and VMA 231 is going to be going away later this month. As you can see, the thing that makes a Harrier specific and unique compared to other platforms is going to be its ability to be able to vertically take off and also land. So what allows us to do that is these nozzles here on the side of the plane. We have 2 nozzles, or 2 on each side, 4 total. We have the cold nozzles here, and then we have the hot nozzles there. As you can see, they're currently pointed down vertically. That's just because we're parked here. And if you ever see us hovering, they'll also be in this position as well. They call them cold and hot nozzles because this is air that's taken from the compressor section, so prior to it being expanded in the engine. And then they call it the hot because that's going to be after the turbine section, and that's going to be after it's gone through the burn phase. So this runs like anywhere from 700 to 800 degrees during the hover, and this is significantly cooler since it hasn't gone through the thermal section of the engine itself. So that's something that's a little bit unique. So starting from the front of the aircraft, this is going to be the Pegasus engine. This is capable of producing 22,200 pounds when we're not using water and 23,400 pounds when we are using water. We have about 500 pounds total of distilled water in the engine, and that allows us to execute or have a little bit of performance with the engine in hot climates or when we're a little bit heavier. As you can see, this is a relatively small intake. If you ever see a Hornet, it's really shoved way back into the aircraft. This engine's a lot closer to the intake, and if you ever are to the side of a Harrier, it's extremely loud, and that's kind of one of the things that contribute to that. A couple other things, we have these boundary layer doors right here. So anytime that we are running at a little bit higher airspeed, these boundary layer doors will get pushed open, and that allows pressure to vent out the top of the aircraft, and that prevents us from having an engine stall. We also have these intake suction doors here. These are going to be on each side of the aircraft. So anytime that we're in a hover and we need a little bit more airflow, since we aren't flying through the air, we need to allow more airflow to go towards the engine. The suction of the engine will allow these doors to open, and we get that additional airflow into the engine. Making our way around, obviously we got the canopy up here, we got our T-handle. This just allows these doors to become unlocked, so whenever we actually do take off, they'll close. We have our pitot probe right here. We have our AOA probe. Obviously this can go with the AOA and let us determine what the AOA is going to be in the cockpit. We have the APG-65, the mighty APG-65, which is behind this radome. This gives us the radar capability that we have for our aircraft. All right, going around to the other side, we also have this FLIR, so the forward-looking infrared, and that allows us to just have the ability to see some things in low-light environments or at nighttime, and also just pick out things in the sky. Over on the left-hand side, again, right-hand side, this is again going to be the other side of the engine. Everything kind of remains relatively the same. The one thing that we can is also part of the vertical component, or things that allow us to hover in the aircraft, is we have the nozzles, and we also have the RCS system, or the reaction control system. So we have a valve on each wing, a valve on the nose right here, and then a valve to the rear. So this is a valve that will open up and shove air down. So whenever we're in the hover, if it shoves air down the nose, we can go back. If this closes, that's reducing airflow, and we can kind of go forward. And if you go inside this door right here, you can see the valves that are part of the RCS system. And this is a pipe that's going to run from the engine, taking bleed air and then shoving it all the way up into that nose, and that's what's going to provide that lift. All right, going along to the right-hand side, this is going to be our main front tire, obviously. This is what we use for nose wheel steering. It's going to be a little bit different than most tires that you see, a little bit fatter and kind of a little bit deflated. That's just the way that the aircraft is designed. If you see other aircraft like an F-18, it's a lot more filled up and a lot more tight. And we also have our targeting pod down here, which is going to be used for being able to pick out targets on the ground, and is going to be used for delivery of PGMs or also GP ordnance. This is going to be our part of our lift system, our lift improvement system. These panels over here and this device, or lift improvement device with the speed brake in the back, allows, when we're in a hover, air to go down, come back up into this box and kind of get captured and holds us up. That provides an additional little bit of lift performance. So if this box wasn't here, it wouldn't kind of capture that air and we wouldn't be able to hover at some of the higher weights that we're able to do so. How we have this aircraft configured right now, we have 7 external stations. So we have, starting from the left-hand side, 1, 2, 3. The T-pod is on 4, 5, 6, and 7. We currently have no stores on the outboard and then intermediate stations. On our inboard stations, we currently have our external fuel tanks. These tanks are going to hold approximately about 300 gallons, so that's about 1,800 pounds of fuel each. That kind of improves the amount of fuel that we can hold by about 3,500 to 4,000 pounds total over our internal fuel system. All right, continue to work our way around. This is again part of the reaction control system. So we have this valve. There's both a opening on the top and then an opening on the bottom. So anytime that we want to go left, this valve is going to go from neutral to closing the neutral to closing the top. So that's pushing down from the bottom, and that allows the aircraft to go to the left. And then vice versa, anytime we want to go to the right, this valve is going to close and then push down on this wing. So this RCS system also runs along the front of each wing, kind of the same piping that you saw on the front in the gear well. This is running along each side of the wing. All right, these are our ailerons. These are our flaps. These ailerons have the ability to droop a little bit whenever in the landing configuration. And then we have the flaps over here. This can go anywhere from 0 degrees all the way up to 62 degrees. So if you ever see us come in for the hover, these are all the way down at 62, and that's what we usually use our vertical configuration for. All right, these outriggers are gonna obviously allow the aircraft to stay balanced whenever we're taxiing around or trying to land from a hover. That's a little bit unique of a system. We have 4 landing gear compared to most tactical aircraft that are going to have 3 landing gear for the tricycle gear configuration. All right, working our way around. Again, these are going to be the hot nozzles. These panels are here to kind of protect the heat from hitting directly on the fuselage. And these are things that can take a lot of abuse. If you ever, one thing we also have to watch out for is kind of our nozzle position whenever our flaps are going to be all the way down. So typically we try not to make sure our nozzles are hitting directly against these flaps because these are so hot that they'll damage these flaps. So if nozzles are aft and flaps are down, then these can take a lot of heat and abuse. And so we try to make sure that those kind of correspond with each other's position. All right, working our way around. These are going to be the buckets that we have our expendables for. So we have 2 30 buckets up here, 2 30 buckets down here. And those are just what we can be used for the expendables for both, just the expendables that we would keep on the aircraft. So that's one of the other systems that we have. All right, working our way back. This is our horizontal stab. This is our vertical stab with our rudder. And again, this is a continuation of the RCS system. So not only is there an RCS valve right here that blows air down, there's also an RCS valve on the left and the right. So as we talked about for the RCSs that are on the wings, if we just want to go left or go right, they open. But if we want to yaw, this is what this RCS system is for, because it will push the tail either left or right. All right. Yep, again, this is going to be the speed brake that we have. This is going to automatically come out whenever we're in the landing configuration. And the speed brake, again, combined with the strakes and the lift improvement device is the whole thing that is that box that allows the hot air to hit the ground, come back up, and improve our lift. Working our way around, you've already seen pretty much all of this. At the very top, that's the panels that go on the top of the engine and to the aft of the engine. You can't see it here, but that's where we keep our water tank and where that 500 pounds of water is going to be stored. So anytime that we need to use that water, it gives us that additional capability. This was not something that was in the very original design of the Harrier. As you can tell, it looks like they were kind of looking for a spot that they can try to stick an aerial fueling probe, and they're like, let's throw it right here. So this probe, whenever it's extended, is going to come out and position right here, and this gives us the capability to refuel airborne. It's a pretty cool system. It is a relatively difficult aircraft to try to refuel compared to others because it's so far to the aft of where the pilot sits. Most air refueling probes are going to be up here in the nose, so that just gives you a little bit better line of sight. So while this is a very good capability of the Harrier, it just requires a little bit more finesse when actually trying to do this airborne. Sometimes we'll have a gun pack on the aircraft. Unfortunately, we don't have any installed right now. It's literally like an add-on system. So you just throw the gun pack on. That will also be a part. The way it's designed is to also provide that lift improvement system in the way that it's designed. And that is going to give us the ability to hold about 300 rounds whenever we do have the gun pack on. It's a pretty interesting system. Unfortunately, we don't have it installed, so you can't see it. Though we do have one hanging out in the hangar, so if you want to look at that later, then we can. All right. So if you're ever pre-flighting an aircraft, once you get done pre-flighting, you're going to come around to the cockpit side or to the ladder side. You got two handles right here. Put this guy down. Put this guy down, and then open the canopy. Just push on the lever, pull, and canopy pops open, and it also lowers this step right here. Those kind of things are connected together, and then you can climb up into the aircraft. Cool. All right, at this point, we're just going to climb up, and we'll be able to go from there. So over here, we're going to have our comm cable right here, which is where our oxygen and comm is going to come through. We have our connection for our our G-suit hose, and that's going to where it's going to take bleed air from the engine and be able to inflate our G-suit whenever we're going to be pulling Gs. A couple oxygen switches. We also have our H2O dump, which is going to be our switch for being able to dump water manually if we want. We have our lights panel here for controlling the lights of the aircraft. We have our fuel panel. We have our switch for being able to pull out our aerial refueling probe, and then also some of our switches for being able to dump external fuel and the pumps that are actually going to be the engine itself. It's going to be the throttle. So this throttle is going to be just forward and back for being able to go faster or go slower. And we also have the thing that is unique about the Harrier. This is going to be the nozzle lever, which is going to manually, no electronic help, pure manual, control the angle of the nozzles. So all the way forward is going to be nozzles aft. That's what we use for conventional flight. And then all the way back is going to be nozzles kind of in the down position, which we're going to be able to use for hover. Attitude and altitude hold system. So this is our saws. That is a little bit of electronic help that we get to be able to fly the aircraft and kind of make us a little bit more stable, both in the hover and then for conventional flight. This is our landing gear. Also down here is going to be our flaps. So this is going to be turning flaps on and off. And then we have three positions. We have cruise, we have auto, and STOL. Cruise is going to be at about 5 degrees. Auto is going to be anywhere from 0 to 25 degrees. And then STOL flaps is going to go all the way down to that 62 degrees whenever we need it. This is going to be our water switch. So we have off, we have takeoff, then we also have land. There's different temperatures and RPMs that we can get water flow. So we have different times when we need water flow and takeoff, and then water flow land. Whenever we're done with it, we just go back into the off position. We don't need it. This is our master arm switch. This is the different master modes. This is our left aim PCD, and then this is going to be our right aim PCD over here. This is our ASMC guy, which is going to be used for being able to manually change different settings that we're going to have, like whether it be fuses or other stuff like that when it comes to dropping any ordnance that we have. Okay, this is our ODU, just another system that we have for being able to select various things on our system. This is going to be our upper control panel, which is going to have our comms and other ways that we can input systems into the aircraft. So our HUD is going to be our primary means of being able to, primary instrument display that we're going to have for flying the aircraft. If this fails, we also have our standby or steam gauges, which is going to be our secondary way of being able to control the aircraft with airspeed, attitude, altitude, and we also have our VSI and then our AOA, which is going to be right here. A couple panels down here, which is going to be for radar, INS, some of the VR systems, FLIR, and then also a couple of circuit breakers down there for controlling the aircraft. All right, over on the right-hand side, we have our EDP, our engine display panel. This is just going to be another manual indication of things that are going off our engine, whether it be duct pressure, fuel flow, and that's duct pressure for PSI of airflow going through the RCS system that we talked about earlier. We have our trim, RPM, JPT for mounting the temperature of the engine, and the amount of fuel or water that we have left. As you can see, it's at 480. Also, this is going to be our indication for where our nozzles are currently at. So as you can see, they're currently pointed down to about 90 as correspondent with the control lever. All right, down here is our fuel panel. This is just going to show us the variation of fuel, or how much fuel we have in the system. As you can see, it's showing about 11,300 pounds. So that's a full load of fuel with external tanks. All right, this is our hides, both in our accumulator, our hide 1, hide 2, and then our brake pressure. We have our volt indicator down here. We have our electrical control panel. We have our backup comm radio, and then we also have a comm panel down here for controlling some other stuff. This is going to be our panel for controlling our internal lights, and then we also have our ECS panel down here, which is going to have cabin pressure, temperature, and then dump valve if we need it. All the way back here is just a couple other DVRs for where we would store our recording device for the flight. A couple of the switches down here for maintaining the engine, and then also you are sitting on the ejection seat, which is going to be our system for being able to egress the aircraft if we need to in an emergency situation.